Welcome to Maths with Bob. Today we're again looking at the parametric parabola, and this time we're looking at the equation of the chord PQ. Okay. Now, first up, let's actually write down what the coordinates of P and Q are. I think that's the best way. We know P is a point where the actually parameter is P, so it would be 2AP squared. And Q will obviously be at 2AQ squared. So the slope, obviously, M, as you know, is y2 minus y1 on x2 minus x1. Okay, so it's basically just the difference in the y values over the difference in the x values, if you like, rise on run. So we just do this one. So if we call the first point P, let's actually just write it above. Sometimes this helps. Just call this one x1, y1, the first point we come across, and the next one x2, y2, the second point we come across. Those subscripts are sort of to indicate the first point and second point, 1 and 2. Now, so let's actually now put it in. So y2, as you can see here, what, aq squared minus ap squared all over. Now x2, you can see here, 2aq minus 2ap. Okay, now we should be able to simplify this, so let's actually just simplify this. I'll change the pen back. Now, okay, so how are we going to simplify this? Well, the first thing is we can see here, this would be difference of two squares on the top, so we're going to get something like what? aq plus p times q minus p. And then we're going to get on the bottom, what, 2aq minus p. Okay, so we know these will cancel so basically we end up getting that the slope is, in fact, you can see there, what is the slope? M, let's write it over here. So the slope between the 2 points PQ, let's call it PQ, is equal to 1 over, so it's just basically a half of Q plus P, or if you like, just write it as P plus Q. Okay, so that's the gradient. Basically, it's the average of the two parameter values, if you like. Now we need to find, okay, now we've got the gradient, all we need to do is just sub it into y minus y1 equals mx minus x1. So let's actually just do that now too. Okay, so we've got the slope. Let's put it into the line. Okay, we know the equation of the line is y minus y1 equals mx minus x1. And we know that the slope is a half p plus q, so it becomes y minus y1 ap squared equals m. We know this is a half p plus q, and then we have a, if you like, x minus x1 to ap. All right. So what do we get? Well, what do we get? Well, let's have a look. Y is equal to, now I'm going to take out minus a half p plus qx. I'm going to expand and move it across. Then what would we have? We'd have on the other side, let's put the ap squared on the other side, ap squared. And let's just try and work out what this would be. It's a half of minus 2ap. So it's going to be what? Minus ap outside of p. Now this is going to be p plus a, well, let's have a look. 2ap, so it's p plus q. Yes, so that's going to be p plus q. I'm just sorry, just see if we can fit that in there. Okay, I think we might just squeeze in on the end. Okay, so we can expand that out and make it minus ap squared minus apq. So this actually works out to be what? Minus apq. And let's actually put it back on the other side to eventually get, let's change the color to, let's change it to red. Okay, so the chord's equation would be what? Y minus a half p plus qx plus apq, and that equals 0. Just to put it in general form. So this is now the equation of the chord, the parametric one, obviously, the parametric chord PQ from the parametric points P and Q, P being 2AP, AP squared, and Q, 2AQ, AQ squared. Okay, so what do we do with this usually? Well, sometimes we actually put make this actually a focal chord. So if this becomes a focal chord, let's actually just see what happens when it becomes a focal chord. So let's actually just rub this. And let's just suppose, actually we may as well rub this out as well while we're here. Okay, suppose this is actually a focal chord. Okay, I just need to rub. This is getting a little bit hard to rub out there. Okay, so here we have the chord. Okay, so suppose it is a focal chord. Focal chord. Now, what does that mean? Focal chord. Okay, well, let's actually just quickly draw a picture. Okay, we know the parabola x squared equals 4ay. We know a chord coming from P and Q. It doesn't matter where P and Q are, let's call that P and Q. Let's actually make it go through the focus here, S at 0a. So that becomes what's called a focal chord now. This is obviously y and x, and the origin here. Okay, and the equation obviously is x squared equals 4ay. So if it's a focal chord, let's sub in x is 0 and y is a. So if it's a focal chord, therefore y, now x is 0, so it's minus 0, then we know that a is the y value, so actually y is equal to a. So this is, perhaps we should actually rewrite that as a equals APQ. Perhaps that's the easiest way of doing it. Okay, yeah. Okay, so now equals 0. Oh, now, what's wrong with that? Well, since I moved the APQ across the other side, this actually should be negative. So we perhaps should write this as minus APQ. Okay, I could write it as A plus APQ is equal to 0, but let's actually just write this, because really what I want is this expression PQ equaling negative 1. Okay, so if it is a focal chord, basically the relationship between P and Q is actually negative 1. Now what does that mean? What is P? Well, at P, you might remember, P was in fact, here we go, the slope of the tangent. And at Q, we had, now, this is obviously not to scale, because if P times Q is negative 1, this actually should be a right angle in here. Okay. And if you look at the point of intersection, you'll find that, in fact, they should intersect at right angles on the directrix. This is called the directrix. Okay, which is a units below the vertex. Okay, so what happens, we can actually prove some of the interesting geometric properties of the actual parametric parabola here. This is an interesting one, and P and Q, basically, if you like, the parameter values at either end of the focal chord will multiply together to give me negative 1. Those particular values were actually indicative of the slopes at those points, or if you like, were the slopes at those two different points. And you can see here the slopes are multiplying together to give us negative 1. Therefore, that means that well, as you can see, the diagram is not terribly well drawn, but they are intersecting at right angles, and you will need the point of intersection of the tangents y value to show that they actually lie on y equals minus a. I think it was actually minus APQ from memory. So they'll actually lie on the directrix y equals minus a. All right, okay, well, thank you for watching, and bye for now.